In this Miami tower, billionaires ride their supercars up a glass elevator to a sky garage next to the living room, but a satellite just found the whole building is sinking into the sand. This is the Porsche Design Tower, a 641-foot monolith rising 60 stories above the Atlantic shoreline in Sunny Isles Beach. Completed in 2017, the approximately $560 million project was brought to life by Dezer Development and designed by the architectural firm Seeger Suarez. It was conceived as the ultimate statement in engineering luxury, a structural marvel built to redefine high-rise living long before its foundations faced public scrutiny. Rising from a narrow strip of Florida's Barrier Island coast, the tower stands as one of Miami's most recognizable landmarks. Its massive concrete shell is a feat of modern construction, engineered to withstand extreme coastal winds while supporting the immense weight of its 132 residential units. But building at this scale requires a flawless understanding of the ground beneath, where architectural ambition meets the reality of Florida's fragile sandy coastline. This design is defined by a patented engineering system, the Dezervator. This automated, glass-enclosed car elevator allows residents to drive their vehicles directly from the street into a high-speed lift. Traveling at 800 feet per minute, the robotic system carries both the vehicle and its passengers upward, depositing them right outside their living room door in a private sky garage. Rather than a mere parking solution, the system functions as a high-status lifestyle statement, turning multi-million-dollar supercars into interior decor. To make this work, 3 independent elevators operate within the tower's core, serving 284 robotic parking spaces. Yet lifting heavy SUVs and sports cars hundreds of feet into the air requires more than advanced software. It introduces an extraordinary shifting distribution of weight. Every ascent concentrates thousands of pounds of moving steel into the center of the structure, adding a complex mechanical strain to the building's load. For the global elite, these skies became some of the most expensive real estate on Earth. Units within the $560 million tower traded as elite financial assets, functioning as physical vaults of wealth. In 2019, soccer superstar Lionel Messi paid $5 million for Unit 4705, a 3-bedroom, 3,555 square foot sanctuary. Other residences, like the 2-story Residence 4204, still commanded $5.15 million in June 2026. Buyers purchased these properties for their symbolic status and high market value. But when an asset's worth is tied to its architectural prestige, the stability of that entire investment relies on the stability of the ground beneath. If the foundation begins to move, the financial security of these holdings moves with it. On December 13, 2024, the conversation surrounding Miami's beachfront towers moved from real estate speculation to hard empirical science. A study published in the journal Earth and Space Science analyzed 222 Sentinel-1 satellite radar images collected between 2016 and 2023. Lead author Farzaneh Aziz Zanjani and a team of researchers from the University of Miami's Rosenstiel School used space-based radar interferometry to track ground movement across the Barrier Islands with millimeter precision. To ensure accuracy, the researchers verified the satellite results against ground-based GPS measurements, establishing a highly reliable baseline for coastal monitoring. Their data showed that 35 high-rise buildings from Golden Beach to Miami Beach were sinking, experiencing vertical displacement between 2 and 8 centimeters. Sunny Isles Beach was a primary hotspot where approximately 70% of the oceanfront towers showed measurable settlement. Among the most affected was the Porsche Design Tower. High-resolution Terrasar X satellite data validated these measurements, detecting between 10 and 12 centimeters of localized subsidence at the tower's footprint. This research replaced public worry with documented geological reality, showing that these heavy structures are physically altering the ground beneath them. The ground beneath Sunny Isles Beach is composed of soft coastal sediments instead of solid rock. This barrier island consists of a fragile mix of young marine sands, silt, peat, and porous limestone. When a 60-story, 641-foot tower is constructed here, it exerts immense pressure. The building's massive weight concentrates hundreds of kilopascals of vertical stress onto these soft upper layers, nearly 4 times the load of a typical low-rise building. This weight triggers a long-term process known as consolidation. Because the coastal soil is saturated with groundwater, the continuous pressure slowly forces water out of the sediment. As this water is expelled, the tiny spaces between the sand and clay grains collapse, causing the soil to compact and the ground above to settle. This settlement is a slow, gradual process that can continue for decades. While these millimeter scale movements require careful monitoring, they represent a manageable geotechnical reality rather than a structural failure. It is the natural consequence of placing hundreds of thousands of tons of concrete onto a shifting, compressible island. While geotechnical engineers view this settlement as an expected reaction, a quiet debate divides the structural and geological communities over what constitutes acceptable movement. One side argues the measured subsidence falls well within the design tolerances of the tower's reinforced concrete core and post-tensioned slabs, presenting no threat of structural failure. To them, the building is performing exactly as engineered on soft ground. But other experts, including University of Houston researcher Pietro Melillo, urge a longer view. They argue that even minor, ongoing settlement creates serious long-term serviceability risks. Over decades, millimetric shifting can shear underground utility connections, crack plumbing lines, and cause chronic water infiltration. When this localized sinking is compounded by a projected 1-foot rise in sea level by 2050, the math changes. The debate is not about immediate collapse, but whether Miami's ultimate luxury towers can maintain their performance for future generations. Physical settling quickly translates to financial pressure. For owners in the Porsche Design Tower, a few centimeters of ground movement can trigger immediate economic consequences. Since 2022, condo master policy premiums in Florida have doubled, with insurance carriers raising rates across known subsidence corridors. Lenders are also pulling back, placing over 1,400 Florida buildings on Fannie Mae's non-warrantable blacklist. This designation blocks conventional financing, forcing future buyers to secure specialized portfolio loans, requiring massive down payments of 30 to 40%. For these multi-million-dollar properties, resale risk rises as buyer confidence weakens, turning minor structural settlement into a major financial liability. The Porsche Design Tower is not an isolated anomaly. It is a symptom of a broader regional reality. Across Miami's barrier islands, 35 high-rises stand on the same compressible ground, facing a projected 1-foot rise in sea level by 2050. This collision of engineering ambition and geology is forcing a regulatory shift. Under the 2026 Florida Building Code, coastal structures within 3 miles of the shore must undergo milestone inspections at 25 years rather than 30. Future towers will likely require foundations descending over 200 feet to reach stable limestone, proving that while human ingenuity can build into the sky, it must ultimately yield to the earth below. Continuous satellite tracking provides the constant data needed to keep this structural shift visible. Engineers have several practical options if stabilizing the tower becomes necessary. Underpinning the foundation with heavy steel case micropiles can transfer the building's weight directly to solid limestone, while jet grouting can reinforce the soil below. But physical fixes are only part of the solution. Restoring confidence in Miami's luxury market requires complete transparency among developers, buyers, and lenders. Managing this future means balancing strict building codes, careful engineering, and financial realism. Thank you for watching. If you enjoyed this video, please like and subscribe for more engineering investigations. As luxury climbs higher, the shifting ground beneath Miami reminds us of nature's limits. The future of this coastline won't be decided by architectural ambition, but by the geology we cannot ignore. Thank you for watching, and please like this video, subscribe for more.